Students, welcome to the part B of this lecture today. So we just learned how to we learned the method of solving a differential equation by the series method when the solution is asked at the ordinary point. So let us try an example. So So this is an example: x square plus 1y double dash plus xy dash minus xy is equal to 0 above the point x is equal to 0. So you see here they have not mentioned whether it's an ordinary point or not. So you may sometimes be asked to find whether this is an ordinary point and then go to the method. But since I have already given you a lot of assignments on how to find or whether a point is an ordinary point for a differential equation or a singular point for a differential equation, we will not go to that part, because as it is, the whole process of solving this differential equation is very long. So we will assume that this is a ordinary point, and so we start with the solution. The solution, what we'll do, solution for ordinary point x is equal to 0. And just to remind you how to find whether it's an ordinary point, what we do is we put in the form y double dash plus px, a function of x multiplied by y dash, plus qx, a function of x multiplied by y, and then we find whether it's analytical at x is equal to 0 or not. That way we find the ordinary point. Now I have left this part proving that this is an ordinary point. So solution for ordinary point, let the solution of 1, let us name this as 1 first, be y is equal to summation n goes from 0 to infinity Cn x to the power n. Now how did we do this actually? This is because in the method that we saw just now in the part A of this lecture, that is the first part of this lecture, we saw that for a power series solution, this has to be n goes from 0 to infinity Cn x minus x naught the whole to the power n. Then what did we do after that? After that, we took its derivative, we found y dash, we found y double dash, and so on. So like this. But then here x naught is 0, you see this one. X naught means the ordinary point. So this becomes just Cn x to the power n. So that's why we have written it in this manner. After that, let this be 2a, or just let it be a. Let this be a, then let us find the derivative with respect to x, so that this is y dash, that is dy by dx. Y dash is within summation sign, n goes from 0 to infinity Cn n Cn Cn x to the power n minus 1. So let this be b, and again we differentiate this with respect to x. I get y double dash is equal to n goes from 0 to infinity n into, again this n minus 1 comes down, so n minus 1 Cn x to the power n minus 2. So this is C. So using ABC, using from here we come here using A, B and C in 1. In 1 means the equation which has been given to us and whose solution is required. So when I put it in 1, what do I get? My equation was like this. So let me look at the equation. This can't be seen from here. It is x squared plus 1. So it is x squared plus 1 into y double dash, which is this one. Summation n goes from 0 to infinity n minus 1 cn x to the power n minus 2 plus x y dash plus x into y dash. So we have y dash here. Our y dash is n goes from 0 to infinity nc into n. See, this has come as a suffix. It should not be. It is multiplied by n, so this will come like this. Even here, okay, sorry. Here it is the suffix. I'm so sorry. I have put the n here. So this is like this. So nc n, yes, this is the suffix. So we were here x to the power n minus 1. So we finished this part too. Now coming to minus x multiplied by y, and y comes here. So y is x into y. So this, and again going from 0 to infinity cn x to the power n, which is equal to 0, like this. Now so let us go to the next page. Let me clear my board. So this method is quite long, as you will see. We will need one period, more than one period in fact, to finish a particular numerical. So you must have noted down in your copies, which implies when you multiply x squared, we had x squared plus 1, so multiplied by x squared, the first term, it becomes like this. It becomes n is equal to 0 to infinity n minus 1 cn x to the power was n minus 2, but multiplying by x square plus 1, so x square, so it becomes xn. I can't show you the previous step, but you have to check it from your copies. Plus n is equal to 0 to infinity n minus 1 cn x to the power n minus 2, because this portion was multiplied at first by x square and then by 1. So after that we come to the next term. This is n goes from 0 to infinity n cn. Again, since x was multiplied here, it became the n minus 1 exponent now became just n. And finally we have n goes from 0 to infinity cn x to the power n plus 1 is equal to 0. Now students, please pay attention. Look at this expression. what happens if I put n is equal to 0 here? When I put n is equal to 0 here, because this is a summation, that means what? First here comes n is equal to 0, this whole expression, n is equal to 1, put n is equal to 1 in each of these n's, then comes n is equal to 2, then comes n is equal to 3. That is the meaning of a summation, which you already know. So when I put n is equal to 1, this expression becomes how much? 0, is it not? Because when I put 0 here, this becomes how much? It gets multiplied by 0, and so this portion. So what I'll do is, I think I'll just look at these expressions one by one like this, so that you don't have a problem here. So we'll look at this one. First, only this one. When I put n is equal to 0, it becomes how much? It becomes just 0. Then I put n is equal to 1. Then what happens? 1 into 1 minus 1. So 1 minus 1 is 0. So again the whole expression, that means for n is equal to 0, we get the value of this expression 0. For n is equal to 1 also I get 0. But for n is equal to 2 we will not get 0, because 2 into 2 minus 1, it is not 0. So students, look at this summation. So can I not just write this expression as if it has started from n is equal to 2 to infinity like this? So as n goes from 2 to infinity, n minus 1 cn x to the power n, can we not write this like this? Because you see, we will first clear this part and then we will go to the next part. Because when something is going from 0, then 1, 2, 3 like this, taking, not going actually, because these are discrete values. It's not gradually going from 0 to 1 and then 2. It's taking the value 0, it's taking the value 1, it's taking the value 2, 3, 4 to infinity. Now, summation means I put the value 0 first in this one, then I added plus, I put the value n in place of n, then plus I put the value 2 in place of this, and so up to infinity we add each terms. But then here we have found that when I put n is equal to 0, this gives a 0 value. When I put n is equal to 1, it gives a 0 value. So it's like adding 0 plus some expression. So 0 plus x is just the same as x. So which is x is what? Is starting from 2 to infinity. So maybe I have justified myself that this expression can be written as n goes from 2 to infinity. Now let us come to the second one, this one. In this second one, what happens? Doesn't the same thing happen here? Because you see, here also we have got n minus 1 like this. So that here too we can assume that this has started from n goes from 2 to infinity, n minus 1 cn x to the power n minus 2. Now what about this one? Here you see, when I put n is equal to 0, this becomes 0. But when I put n is equal to 1, it does not become 0. So here what I do, I start the summation from n is equal to 1 to infinity. So I'll stop my class for a small break and we'll do the remaining part in the part C of my lecture.